Hi, welcome to this video on momentum and impulse. So we're here to answer two questions: what's momentum and what is impulse? Beginning with momentum. Momentum is defined as mass multiplied by velocity. So you can easily work out the units for momentum by multiplying the units for mass and the units for velocity. The units for mass being kilograms and the units for velocity being meters per second. So the units for momentum are kilograms meters per second. Now we measure things in mass and velocity, but we don't usually measure things in momentum. So it can be difficult to get an idea of what is momentum. What is it day to day? Well, if you think about two people running at you, big bloke like me running at you, big M, I have a big mass than a smaller bloke. If I run into you very quickly, you're going to experience a big force on you. If I run into you very slowly, you're going to experience a relatively small force, even though you still probably wouldn't like me to do it. If a smaller, skinnier bloke with a lesser M, he weighs, he has a lower mass than I do. He needs to run into you harder. I shouldn't say harder. He needs to run into you faster to exert the same force on you as I did, because my M is bigger, my V can afford to be less, and the skinny man, since his M is smaller, his V must be greater. So, to get an intuitive idea of it, it's not scientifically correct. It's the force you experience per unit time, just about. So let's say we both hit you, big guy, smaller guy. He's running faster, I'm running slower. We exert the same force on you over the same length of time. Now you'll think, momentum, so it must just be a number then. If it's mass times velocity, it's just a number. Say if a lorry comes towards you from your left, I don't know if this is left on your screen, but a lorry comes towards you at your left and exerts a force on you in the same direction, so it will push you that way. Its momentum might be, say, 10 kilograms meters per second. But a lorry coming at me the other way is also going to have this force of 10 kilograms meters per second. But it's going to be in the other direction. And you'll know if you've done any other physics or mechanics that if something has a direction like that as well as a size, the 10, then it's called a vector. And this makes sense when you think about it, because if we look at the definition of momentum, it is mass times velocity, and you'll know if you've done any mechanics that velocity is a vector. Velocity has a direction, and it's the velocity that determines the direction of the force that you experience when there's the change in momentum. So the lorry coming at me that way has the negative of the velocity of the lorry coming at me that way, because they're travelling in opposite directions like that. Their mass isn't changing. Their mass is the same, but their velocities are in different directions, therefore the forces they exert are in different directions, therefore momentum, like velocity, is a vector. If you want to skip the next few seconds about the scalar and vector quantities, if you're not too bothered about that, then just click somewhere on the screen and it will take you to the summary. For the more advanced, you'll notice that M in this is a scalar. It doesn't affect the direction of the vector, it only affects the magnitude of the vector. So it makes the line, if you will, longer, but not change direction. So what is momentum? Momentum is measured in kilograms meters per second. It has a direction because it's mv, and v has a direction, m doesn't. So the momentum vector is in the same direction as the velocity vector. Now let's move on to impulse. What is impulse? Well, first you need to know about Newton's laws. Click somewhere on the screen and it'll take you to my video about Newton's first and second laws, are the ones we'll need for this. Newton's first law, as summarised in the Newton's first law video, states briefly, I'll summarise here, that things tend to keep going if there's no forces on them, and they tend to stop if they're already stopped and there's no forces on them. So things do what they're already doing as long as there's no force on them. So Newton 1 tells us that the change in momentum of something will be 0 as long as F is 0. Newton 2 tells us that the rate of change of the momentum of an object is proportional to the resultant force exerted on the object. So in symbols, we can write this as delta mv, which is the change in momentum, over delta t. Anything over delta t is the rate of change of something, it's how quickly it's changing. So we have delta mv over delta t equals f. So we have f equals delta mv over t. Now you might be able to spot, if you can write delta v over t as something else, we can make this simpler. So what is delta v over t? Delta v over t is the change in velocity over time, which is also a, acceleration. The change in velocity over time is just the acceleration over the object. So we can take the delta v over delta t out, cancel those, and it turns into F equals ma, which is more commonly what people call Newton's second law. And if you've done M1 maths, you'll know that F equals ma is what you call Newton 2. Now if we take our new equation, the more complicated one, F equals delta mv over t, and multiply both sides by delta t, you get F delta t equals delta mv. And now this thing, this quantity that we get, F delta t or delta mv, they're exactly the same because they're on either side of equal signs, they're called the impulse. That's all impulse is. Impulse is force times time. Impulse is also the change in momentum. It is delta mv. That's what delta mv means. It's the change in momentum. So if you have a graph of force exerted on an object as a function of time, then the area under that graph is force times time, which is the impulse. And then you can use that to figure out different things. For example, if you have a graph of force against time, and you can figure out the area of it, you know this area, let's call it 5. 5 equals mv. If, say, this is a ball bouncing off a wall, then, and you know m, then you can divide 5 by m, and you'll find out delta v, which is the change in velocity. So impulse can be utilised to find out things like that. So what is impulse? So what is impulse? As a summary, impulse is the product of force and time, and it's also equal to the change in momentum of an object. This is helpful if you have a force-time graph. You can figure out the area underneath, F delta t, and this is equal to the change in momentum. Hope this has been helpful. Please check out some of my other videos and stick around. Thanks for watching. Bye.